Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics Chapter 5 Probability Distributions Long Question Example 1. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. A company has 5 telephone lines. The probability that a line is busy at any moment is 0.4. Find the probability correct to 4 significant figures that at any moment all the lines are busy. So this is for the question part A. For the question part B, more than 3 lines are busy. And for the question part C, at least 1 line is busy. Okay, so this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Okay, before moving on to solve this question, okay, this question is actually involving the concept of binomial distribution. Okay, if you are not familiar or if your knowledge of binomial distribution is not strong enough, okay, I recommend you to click on the link above and watch that video first, because I've discussed the explanations and some of the basic examples behind the binomial distributions, which I hope that it will help you guys. Okay, so let us proceed our discussion now by begin with the question part A. Okay, so since I mentioned that in this question we are going to use the binomial distribution, so throughout this question we are going to use the binomial distribution formula most of the time. Okay, so if you don't know the binomial distribution formula, don't worry, I'm going to show you now. So this is the binomial distribution formula that we are going to use. So please take a look guys. So this formula is the one we are going to use for our guidelines. Okay, so let me write the question part A over here. So whenever you see a question involving a binomial distribution, the first step what you need to identify is the number of trials. Okay, in this case the number of trials is representing the 5 telephone lines. Okay, so this 5 telephone lines is representing the number of trials. So in this case we can write our number of trials n is equals to 5. Okay, so this is the first information. Okay, the second important information that we need to obtain is the probability of success. Okay, so how to know in the question which one is probability of success? Okay, in this question they are emphasizing that the probability that a line is busy at any moment is 0.4. so this is the probability that they are emphasizing by the question. So you can assume that, so this probability is a probability of success. So in this case probability of success we can write in letter P, where it is equals to 0.4. Okay, and then the third information that we need to find is the probability of failure. Okay, in this case the probability of failure is Q, letter Q. So from here you get the letter Q is 0.6. Then you can ask me, so how you get this 0.6? It is very simple. So from here, to find the probability of failure will be equals to 1 you minus with probability of success. Okay, so that is how I come up with the 0.6 value here guys. Basically I use 1 minus 0.4. okay, and that's how I got this 0.6 over here. Okay, so whenever you encounter any binomial distribution question, so these 3 information is a must. So you must have number of trials, you must have probability of success, and you must have probability of failure. Once you have all this, then you can able to solve most of the questions. Okay, so in this case for the question part A, they asking all the lines are busy. Okay, a company has 5 telephone lines, and in this case all the 5 telephone lines are busy. Okay, so from here you write in the statement form first. So from here, probability all lines are busy. Okay, so in this question how many telephone lines we have? So we have 5. So from here we're going to set our probability in terms of the binomial discrete, where our x equals to 5. Okay, you have 5 telephone lines and all the 5 telephone lines are busy. So from here, let us proceed to calculate this. Okay, so we use the formula, binomial distribution formula. Okay, so from here 5 C 5, okay, the C stands for the combination, which you learn in the permutation and combination chapter. I hope you can able to recall it. Okay, 5C5, okay, and then you times with 0.4, okay, to the power of 5, okay, and then you times with 0.6 to the power of 0. So the number of trials in this case is 5, and the number of success event in this case is 5, because you have 5 telephone lines and all the 5 telephone lines are busy. So that's why you have 0 failure over here. Okay, so you calculate this. So from here you should get your answer 0.01024. Okay, let me underline the solution for the question part A. Okay, so let us proceed our discussion for the question part B, where they ask us to find the probability that any moment more than 3 lines are busy. Okay, so let me write down in the working over here, starting with the statement form, then I convert it to the equation. Okay, so from here, probability more than 3 lines are busy. Okay, close bracket. So from here, you need to find the number which is more than 3, and it must be fulfilling within the number of trials. Okay, in this case, you can have your number of busy telephone lines where your P in a bracket X equals to 4. You can have 4 telephone lines busy and 5 telephone lines busy. Okay, so from here, P in a bracket X equals to 4 plus with P in a bracket X equals to 5. Okay, some of you can ask me, so why you don't include the number 3 here? Okay, you must read the question carefully. It mentioned here more than 3 lines. Okay, so more than 3 means you must start at least with the number 4 over here, and you must include the number 4 and number 5 only. You cannot include the number 3. So I hope my explanation are clear over here. So from here, once you identify this, so the rest you just apply the formula. Okay, so from here, so out of the 5 telephone lines, 4 telephone lines are busy. So from here, the 5 you choose for 5C4. Okay, and then you include the probability of success. In this case, is 0.4. Okay, and then you include the number of trials here, which is 4. Okay, I mean the number of success, guys. Okay, in this case, the number of success here is 4. So, and then you times with the probability of failure, 0.6. Okay, and from here, the 5 you minus with 4. So from here you should get is 1. Okay, the 5 you minus 4 you should get here is 1. So, and then you plus. Okay, so this is the calculation for probability where your X equals to 4. So let us proceed to our calculation where your probability X equals to 5. Okay, for probability X equals to 5, you have already calculated in the question part A itself, so it will be slightly easier for us. However, we just write down the working over here just in case. So from here, plus 5C5, okay, and then 0.4 to the power of 5. Okay, so this is the number of success event. So from here, so this is the trials, and then this is the number of success event. So 5 you minus with 5. So from here, this is your probability of failure and power of 0. Okay, so you calculate for the probability X equals to 4, you should get 0.0768. Okay, and then you plus with the probability for the X equals to 5. Okay, for the probability X equals to 5, you have already find in the question part A, which is 0.0102. to 4. Okay, you calculate both of them, you should get your answer 0.08704. Okay guys, make sure you give your answer in 4 significant figure. Okay, you should be very careful. Okay, read the question carefully. You must give your answer in 4 significant figure. Let me underline the solution for question part B. Okay, so from here, let us proceed our discussion for the question part C, where they ask us to find the probability that at least one line is busy. Okay, from here, let us write down the statement form. Probability at least one line is busy. Okay, so from this statement, we are going to convert into the equation form. So from here, at least one line is busy, that means they're including the one also in this case. So from here, it meaning that you can have one line busy, 2 phone lines busy, 3 phone lines busy, 4 phone lines busy, and 5 phone lines busy. So in short, you can write in this way, where probability in the bracket x more than equal to 1. Okay, so from here, let us proceed to calculate. So from here, for this type of question, the calculation will be slightly different. Okay, you can choose to calculate like this, where probability x equals to 1, and then plus with probability x equals to 2, and then plus with probability x equals to 3. Okay, and then so on until probability x equals to 5. Okay, yes, you can do that, but then the calculation will be tedious. So from here, we are not going to do this way. Instead, what we are going to do, okay, so let me erase this. Okay, so what we're going to do here is, so instead of doing a long working, we are going to use the shortcut over here. So the shortcut will be 1 you minus with the probability where your x equals to 0. Since in the upper probability you are including the x more than equal to 1. Okay, the only probability you're not including is the x equals to 0. So from here, the calculation is still the same. So what you do, 1 you minus with the probability x equals to 0. So from here, 1 you minus with the probability x equals to 0. Okay, x equals to 0 will be 5 C0. Okay, from the 5 trials, okay, you find out that none of the telephone line is busy, which is technically is good, right? Okay, so from here, 0.4, which is the probability of success, is actually 0. Okay, from here you include the probability of failure, which is 0.6. Okay, so the number of trials you minus the number of success event, 5 minus 0, so you left with 5. Okay, so you calculate this. So from here you get your answer 0.9222. Okay, so this will be your answer for the question part C. Okay, let me underline the solution for the question part C. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Any comments, feedbacks or questions, feel free to put it down in the comment section, guys. Thank you everyone for your support, and I'll see you in the next video.